Hi, welcome to Art of Academia, a weekly podcast featuring interviews with leading scientists and insider takes on life in academia, hosted by Komal and Madan, researchers from Cancer Science Institute, Singapore.
What's up?
Oh, what is up? We just did some Jimbro stuff.
Yeah, we did.
It's a major arc now of being a Jimbro. We did Kentridge Games, which was competition at our gym. Teams of 4 was intense. Not that tiring, but good fun.
Yes.
Yeah, I was telling you earlier, I really felt this competitiveness or just this energy after a long time.
Mm-hmm.
And I feel like I should try to get more of that somehow.
Yeah, it was good fun. It is true that we've become very much gym bros, going gym every day, and then doing all these competitions. But it's nice. I am enjoying it.
Yeah. How are things on research end?
Research end, it does feel like I've been stagnant for a while. And that's mostly because don't have very obvious leads on what to follow up on. And
also, I guess method development and
exactly. So all the things that I'm doing right now, none of it are things we know how to do in the lab. So there's a bit of troubleshooting quite a bit of troubleshooting that goes into it. And I think it's also a little bit of my weakness where there's many things in parallel and then they all take time. So you just have to do them at the same time, make little bit progress on everything as opposed to zooming into one thing and just doing that. It just doesn't work like that. So I think hence it feels like it's been stalling. And I guess in the recent weeks, another reason also is that I was trying to get some experience into grant writing. So that took a big chunk of my time.
How did you find that?
That was good. I think I had the idea. I was excited for it because it was novel in a sense that it was an original idea, according to me at least.
Sure. That is exciting.
Yeah, and the nice thing about it is I think I found a good balance in different forms with that project, with the idea that I'm proposing. One, it leverages a good amount of computational work, right? Which is exactly. I want more bioinformatics in my work, so that's nice. But it still does not. It's not entirely computational. It requires some wet lab validation, which is good because I think it just adds more weight to it, right? You can be sure that this is real and not just some artifact. The second way in which it is, again, well balanced in my opinion, is that there's a bunch of new things we need to do. So for example, mostly on the computational end again, I'm proposing that we use some of the latest, some AI models basically to do some predictions. So that would mean I would need to learn how to use them, how to fine tune them, how to train them, do predictions with them, which is exciting. But again, the balanced part is for the wet lab validation, most of it does rely on things that as a lab we have expertise on. Yeah. And I would even say maybe competitive expertise.
That's always good.
Because it leverages the mass spec, which not a lot of people do. Yes. Some DNA pull downs. So that way it's nice.
Yeah.
So I feel
mix of both. Yeah, I think it is pretty balanced where you learn new things, but you're also confident in some other parts of the project.
Yes. And maybe the final place where I in my opinion, it's well balanced is it has a strong basic biology foundation. And to be fair, my original idea was entirely basic biology. Yeah. Right. It was just a purely curiosity driven question. But based on feedback from my mentors and also I showed it to a few people, their thing was to turn it into a bit more applied proposal, which makes sense because in the Singapore environment they are very translational, very application oriented.
100%.
So I think the stage it has turned into now, in that sense also it's a bit more balanced. And probably if I ever do officially write the grant, which I will, maybe not immediately but at some point, then I would probably lean more into the application side of it.
It's also mostly you have a bigger overarching question and then say 3 aims. One can be very, very purely basic, and one a bit hybrid, and the third one can be absolutely translational. So you feel like...
Of course. But it was a good exercise. I'm glad I got all the feedback.
Nice.
but I think I'll probably take a little break. I'm not going to jump right into
Yeah.
the writing because the deadline is soon, right?
It is
it's
soon.
June or July.
Yeah.
So the idea for me anyway for this grant, the other thing they said that
Also, just funny, like just a sidebar, but how the conversations have changed. Like
As in
how
talking about grants
writing
now.
a grant is such a normal thing now.
Yeah.
Like last year,
probably not
none of
even
us
in
spoke
the
about
yes.
it. Anything else?
What else? How's your stuff? How's your work going?
Yeah. Did we talk about AACR? Maybe not. So I basically went to AACR conference, which is like this big cancer conference in the US. It happened in Chicago this time. And it was my first time going to the US, first time attending such a huge conference. It was mind-blowing because firstly, all the biggest scientists in the field, like all these people that you see on papers, were there. And some of their talks were also so nice and inspiring. So I think all in all, it was also a lot for me because there's just so much happening at the same time. This big building filled with rooms and people are running. It's like literally like we're back in the uni. Seriously running because
To make it across.
It's a big auditorium. There's like north, south, east, west, and you're looking at your app schedule. There's an app, and you can see where is the next talk that you're interested in. And if you were in the south and it's in the north and starting in 5 minutes, GG.
Yeah, time to run.
Apart from that, I really liked the vibe as well. People seemed very open, very enthusiastic. So I think maybe if you go to such an event, maybe once a year or once in 2 years, it's a nice motivator. It's just a nice place where you can just see all that's happening in the world. It's such a general conference. It's not like focused on one specific field. Because when you do that, when it's so specialized, sometimes it has pros and cons. If it is too specialized, you can get real insights, but it can also be boring.
Yeah.
And here it was like 4 days of everything cancer.
Yep.
So you can seriously just pick something, go sit, and just see if something clicks, if something is interesting. So I think for bigger PIs and like senior people, it's the best place to establish collaborations because you can just see, oh, this guy just spoke about this, I do the same thing, let's just go talk. And for people like me, I didn't speak to anyone. I was that introvert who was just like listening and then going off to my hotel to sleep.
Yeah.
But I think overall that's what I picked up. Like initially I was also very blown away to be like, man, I want to move here, I want to come here. But then slowly I calmed down and I was like, just coming here once or twice in 1 year frequency would still be enough to get that high, just to get that excitement for science and then come back and do your own thing. So that was one very nice, very good experience. Got decent feedback on the work as well, which I should be hopefully wrapping up soon. Got a grant.
Yes.
Super exciting. So I wrote this grant earlier this year to IASLC, which is the International Association for Study of Lung Cancer. Basically they give grants to all of these regions. So I got the grant for Asia region. And I think maybe they have like 5 to 6 regions, maybe, probably. And I will be looking at basically chromosomal instability in lung cancer in never smokers. So in the thing that I was looking at, I found that these cancers which come in people who never smoked but have some oncogenes such as EGFR, they show higher chromosomal instability than the ones which do not have this mutation.
Mm-hmm. But these are also non-smokers.
Yeah. So, and by chromosomal instability, I mean in the DNA, normally you have a proper structure of 23 pairs of chromosomes, and however in cancer, there can be a lot of damage to them, and their structure and numbers can differ, and that's called chromosomal instability. So that's the overarching idea, and then I'm trying to understand what are the co-mutations or copy number alterations, or basically what are the things that are helping these cancer cells gain this instability, and can we target it? So the initial part will still be analysis, which I'm working on, and then we will pick up a few targets and then see how they play about in the cells. So that is exciting. I think it's also a good indicator of progress, and just generally like, you have the money now to do yourself. So let's see how that goes. What else? I'm also thinking, like, from the conference itself, I had a few ideas. So one of them is, this guy Paul Michel, who works. You know him. He works on ECDNAs.
Oh, I see. I see
that.
Right. I don't know.
He gave a talk there as well, and I just like him.
He's a good speaker.
Like exactly, and interesting science as well. So now I'm also looking, like, this is sort of a side quest I am on right now. So these are basically, so normally you have all the genes on the chromosomes, but because of chromosomal instability or because of any sort of major DNA damage, some of these oncogenes can also form small circles which reside outside of the chromosomes, and they can replicate, they can go into the daughter cells, and because they are not following the normal cell division, they can increase the intratumoral heterogeneity a lot. They can replicate a lot, and then suddenly, say, normally if a cell divides, it should get half DNA, but because these ecDNAs, these circular guys, can replicate and go to whichever way, they can suddenly increase the copy number or the abundance of a gene by, say, 10, 20 times. So a lot of cancer cells seem to be taking advantage of this, and a lot of oncogenes like MYC, TERT, etc. reside on it. They could be drivers. But basically, in our cohort, what I see is that on these ecDNAs, potentially ecDNAs, I see a lot of immune modulators. So these are genes such as interferon gamma, lysozyme, etc., also present on these ecDNA structures. So that could also be an interesting way to now test if it's not just the oncogenes, but also some of these immune-related genes, which could be transferred to these daughter cells in this wrong cell division manner, and how they can affect now the immune environment and their progression. So yeah, thinking of that like that. Oh, grand or not, in any way, it's an interesting new quest for me.
Interesting. A lot of work.
All right. What else? Let's get into what we were planning to do.
Yes. Okay. So what we're doing today is going over this news feature in Nature, and the title is The Most Cited Papers of the 21st Century. So basically, Nature did an analysis to figure out which papers were cited the most from the last 100 years, and try to figure out why they were so popular. The list, I guess if you didn't look at the list, I might have said a lot of it are probably going to be method papers, because some
What
method...
would you have guessed?
I would have actually guessed the qPCR one, because I think I already knew about it, sort of.
I see.
I don't know where
That's surprising to me.
I see.
Yeah.
I don't know where I know it from. I don't know if I explicitly read it or like somebody mentioned it to me. But I didn't know it was going to be so high.
Yeah. Insane.
And I think that's overall true. A lot of them are methods. The surprising one, which, I mean, not surprising, I just didn't expect it, is the Globocan stuff. But it makes total sense. For context, yeah, exactly. Context,
I cited it.
It's global cancer statistics. And I think they have a very nice website where you can look up the incidence, mortality of different cancers across different geographies.
All sorts of demography.
So pretty much anybody who works on cancer probably starts their introduction from the...
According to Globocon.
Yeah. This cancer is the most deadly, right?
Yeah.
So no wonder that is on there.
And why are they at like spot 9 and 10 both? What's the difference?
Different years.
Just different years.
Yeah.
Wow. Crazy.
Yeah. And then the rest, a lot of it is AI stuff.
A lot of it is AI stuff, yes.
It's all, and then they seem like they're all mostly methods. The one outlier is number 3 maybe, which is using thematic analysis in psychology, which is pretty crazy. I didn't know there were so many psychology papers to begin with, but yeah, probably there are to amass such number of citations. The top 10 I think that's mostly it. We have qPCR at number 2, representing the mall bio world. I guess the interesting thing was I might have expected some COVID papers, but perhaps
It's so soon.
I guess so. Yeah, maybe it just hasn't accumulated. But the GlobeCan 2020, for example, is on the list, right?
That is true.
I guess this COVID maybe not. It was a big boom, but perhaps overall, maybe not that much. Like maybe not one single paper or something got a lot of it.
Yeah, exactly. I think I was reading something else, and it was talking about the number of papers that came out, and that was massive. But maybe not a lot of people are citing those. It's just that small bubble. Whereas for cancer, I guess, given it's so many cancers, whatever field you're working on, you will go and cite just this one source, which talks about so many different diseases, basically. Whereas COVID is just one single disease.
Yeah. And I guess this is also where they themselves issue a caveat where a lot of these citation analysis, I guess they are, there's a lot of biases in them. Like they're not really comprehensive or like accurate in many ways, right? Because there's always exceptions to the rule. So for example, the QPCR story, that's a good one.
Let's dive into like one or two of them just to go a bit more in detail.
Yes. So the second most cited paper on this list, it's basically analysis of relative gene expression data using real-time quantitative PCR and the 2 power minus delta CT method. So it's interesting because apparently for the longest time, the method itself is very old.
Yeah.
And everybody uses it, but there was nothing to cite, right? Because it's just a common thing that emerged out of somewhere. Nobody kind of knows who made it up, but everybody uses it. Then one day, this guy called Thomas Schmidtgen, I guess he wrote a paper and he used some qPCR and he cited the technical manual of the product he was using. And the reviewers were like, you can't cite a manual. So then he decided to talk to one of the original creators of the equations and then made a paper.
Yeah.
And since then because now that something exists that's citable, it has just amassed so many citations, which is true. I guess there's a lot of things we do, like maybe Western blot probably does not have a paper, right? And nobody cites it. But if you did, they might climb up very quickly.
Yeah.
And I think they even say that in the text somewhere that if you ever make a method, make sure you write a paper.
I mean, now I guess it's such a normal thing to do. I guess maybe like now people create methods to even just publish.
Yeah, that nobody's going to use. Yeah. That's true.
So now it's just a way of actually just writing something, getting some increase your H index or whatever. But I guess back then people didn't really think about it.
I think in bioinformatics, some of the OG tools were like that. I think the tools probably came out first, and then like after they got very popular, only then the papers.
Yeah, maybe like the journals also later on realized that we should have these specific journals just for methods. Because now if you created a method and you wanted to submit it to some general journal, it might not get picked up because it doesn't talk about any biology.
Yes.
And now the emergence of new method journals is boosting this whole field, which is cool.
Sure.
Which is cool. I think even if you go to top 20 instead of the top 10, a lot of bioinformatics tools do show up.
Oh.
All the bowtie, SAM tools, alignment tools, ddct for RNA analysis. So I think those guys are the most cited if you go further down the list. Okay. Number 3. Did you know about this thematic analysis?
No.
So number 3 most cited paper is called Using Thematic Analysis in Psychology, published in 2006. And overall, it's just really identifying like meaningful patterns or themes in qualitative data. So if you now think about non-hard sciences where you're like doing surveys to understand so much of any question in psychology and how to now analyze that. So this paper is literally just giving a tool to do that or like just a method to do that. So if you had done a lot of interviews or you have a lot of text data from people's opinions, it follows like 6 steps, which I just Googled. Read data, then find themes, and then within those, so for example, if a lot of people, for example, the question was, how is, say, Instagram affecting your mental health? Some general question like that. And then people are telling you things, and now from those texts, you are trying to find out themes. 10 people said some things, and then if you say one thing was distraction, or one theme was motivation, whatever. So you create these things, and then within those themes, you are trying to collate the data. Then you review, you name those final themes, and then you report. So that's just how to sort of quantitatively analyze qualitative data. And I guess like a lot of psychology papers or research is based on stuff like that. Because I remember like a friend of mine back in during my PhD, her PhD was in criminology. And what she would do is she used to go to prisons and speak to prisoners about their experiences.
Damn.
Yeah, hardcore work. And I used to actually ask her, but I never had a detailed conversation with her. But and there also she was actually speaking mostly to females, female prisoners, and how now living here in this prison affecting like their mental health, how is it affecting their self-esteem, lack of a partner, if their partner is somewhere else, if they are creating bonds within this prison. Like it was very strange and like
Yeah.
interesting things that she was doing. But it's basically going to so many different jails and then collecting all this data. And there's so much heterogeneity in this data as well, right? If you're in a jail in the North India versus if you're a jail in a South India, so many factors play into the psychology, into the experiences that these women have had. So I guess she must be following something like this to. It must be like standard practice for people like her to report the data.
Yeah. I mean, we did have a course which was basically bioethics. And so the first half of the course at NUS, they designed it so that the first half is like mostly philosophy. So they teach you the basics of philosophy.
Yeah.
But the second half, the entire second half was just empirical bioethics, which is again...
What does that mean?
Yeah. So the only way you're empirical in philosophy or this kind of thing is surveys. So it was all methods. It was like, how do you ask questions? And then how do you what are the different kinds of questions?
Yeah.
So I guess that is their best attempt to turn something which is inherently not empirical into... I mean, I guess for them it's empirical, but as close to empirical as it can get.
Yeah. Did you guys do any project there? Or it was more just theory?
We did have to do. Did we actually do a survey? No, I think what we did was we made some questions. We crafted the survey, but we didn't conduct the survey.
Right.
So
Yeah,
we
that
just
must
show
be like a process in itself, how to create a survey which will give you data that you can eventually analyze.
Yeah.
It shouldn't be so qualitative.
Yeah, I mean, to be honest, the quantitative survey part was my least favorite thing about the module, which was unfortunately half of the module. The module, at least the first half again, mostly would be like they'll give you some material to read up. So before class, they give you a bunch of essays.
Yeah.
So let's say we're talking about, now I cannot remember how the classes were structured, but like it's logic now. And then they'll give you a bunch of essays for you to read up on it. And then the class will mostly be questions and discussion, which was a very nice way to conduct the class.
Yeah, I did have a friend who was doing masters in also some arts field. I should know something in education. Am I the air quotes? Something in real education.
Keep that in.
They can't see my air quotes.
You said it out loud.
But anyways, like that, her was also like you do so much reading, and then just the class is literally just discussion. And even in ICER, actually, we had every semester there will be 1 or 2 humanities course, HSS courses, and these were like nice people, very nice people, and there was just so much reading, and the classes were literally discussions or some presentations, stuff like that. It was very nice.
Yeah, we even had a essay to write, and I think that was one of the most fun assignments I've ever done in all my life. It's pretty good.
Second arts masters.
No though. CBA.
Okay, cool. Then we have on number 4 is something called Diagnostic and Statistical Manual of Mental Disorders, DSM-5.
Gives famed vibes.
2013. Whoa.
As 3.
Whoa.
What?
Yeah, I'm just kidding. It is specifically a rule book for mental health disorders. So more like psychiatrists or like mental health professionals are using this. But you just name a mental health disorder, and then it can give you a list of symptoms, surveys, questions that they will use to analyze a patient. And the funny thing is, I think I just Googled this maybe, and now I got a meme on Insta for DSM-5.
Damn, that is so specific.
That's so specific. So basically, I was just scrolling through, after doing whenever I did this, I was scrolling through Insta, and then there is this meme where, it's insane.
Guys, at least pretend like you're not listening, right? This is ridiculous.
Then also the meme is like, normally my memes are just like some coupley stuff, like the girl is being something and the boy is whatever. Like
DSM-5 meme now.
Yeah. So now the guy, like the girl is standing and the guy is looking at her, and the caption says, "You seem like a girl someone will write a book on." And that happens and she's smiling and all. And then the next page is
DSM, this man, yeah, I see.
I'm like, oh my god, what is happening?
That's a good meme though. I know a few people like that.
It was so hilarious.
I don't know if I really want to cover all the AI stuff. Maybe is there like any higher order?
Yeah, there's a lot of AI stuff. Maybe we can talk about random forest, and I just like high level Googled some other things, which obviously I don't understand much. But okay, so number 5 is some tool used in crystallography called Shelx. Yeah, I guess it's just some big tool that they use to process X-ray data for understanding crystal structures. And number 6 was random forests, which is a machine learning algorithm which helps in predicting or classifying. So, for example, I can give the way I have used it. This is the only ML tool that I have used ever. So, what I do is I have a lot of data from cancer patients. And so, for example, I have 100 patients that had a particular cancer. And I now also have a lot of features for all of these patients, which could include the type of mutation they have, their age, their gender, their, because I have genomics data, I can also look at mutational signatures. I also have their transcriptome data, so what sort of RNA pathways are on, off, things like that. So for all of these 100 patients, now I have all of these features. And using these features, can I predict if they will or will not relapse eventually, which means if they will again get the disease or not. So from these 100 people, I already have the labels. I already know how many of them eventually relapsed or not. So let's say 50% relapsed and 50% did not relapse. Now in this tool, I will provide their features, which were say 10 features, including genomic, transcriptomic data. And I will also provide the labels, relapse or no relapse. And now the tool will use, you can tell it that use say 80% of the entire data as training and use the rest of it, 20% as test. So during the training now, what this model is going to do is create a lot of trees of yes and no. So it will start with say TP53 mutation, yes or no, yes, okay, then it moves on to ask a next question, yes or no, then it goes on to ask the next question, if SDS2 is there, blah blah blah, things like that. It will create so many different trees. And then I mean, I don't understand the math exactly, but it's kind of like it gave me an example of it, kind of like is instead of asking one expert, you're asking a crowd of experts. So all of these trees are now a crowd of experts, and now you have a model where now if you have a new patient, you have the same features for them, throw that in, and you can ask if they have a high risk of relapse or not. And that's very useful in our field, of course, where you're looking at cancer patients, but it can also work in a lot of other fields. Then this paper on rank 7 is called Attention is All You Need, which was published in 2017, I think by Google and some collaborators. And they introduced a tool like an algorithm called Transformer. And it is basically NLP, I want to say. It's a natural language. What's P? Programming. What NLP does, do you know?
From what I understand, it's just a way of working with like text. Like for example, you can give it like a sentence, and then you want to find ways for the machine to understand how to interpret that text.
Yeah.
So, but there's different methods.
Right. So with this background, if you had a sentence, and normally a tool will go word by word to interpret this. So for example, let's take an example of you wanted to translate a sentence. A cat sat on the mat, something like that. Now a normal tool, I don't know which one, but something that existed previously, would go through it word by word to translate it. It takes time, it takes compute power, and it sometimes can also be wrong because by the time it has reached the last word, the memory is kind of gone. So what this tool does or Transformer, which was published in Attention is All You Need, I like the title, is that now from this group of words, just pick up keywords. So if the sentence was a cat sat on the mat, you pick up the keywords cat sat mat. And now you use that and then do whatever math you did, and you just focus on that to do the translation. And that's how you obviously reduce compute power, and then overall the efficacy and accuracy of the translation, or just generally understanding the language, and then prediction models and stuff can also improve. So ChatGPT, for example, also I think uses something similar. And that's how it is able to do these predictions or like give you this data faster and more accurately.
Interesting. I do hear this word a lot in like lab meetings with Jason. We have one RA, who's a computer science background and a lot of ML AI stuff. And she does talk about attention a lot, but I never truly grasped the concept.
I see. Yeah, I mean, yesterday when I was reading through, I did a little dive into like just some videos basically, but it's difficult to grasp, of course. But I just got like a little flavor of, basically you have this AI like big umbrella, and under that you have machine learning, where you do mostly things like classifications, predictions, and then you have deep learning where you're using neural networks, whatever they do. And then you have the NLP, or these large language models, which are working more with language, words, as opposed to numbers or tabular data.
Right.
It's the format of data that you're looking at, and then what sort of output you want.
Cool.
Yeah. And then I think a few others were also more on image recognition tools, which use a lot of neural network. So I don't want to go into deep, but yeah, they seem super popular. Number 1, number 9. Recent as well, 2016, 2017. So I guess, yeah, this image recognition, which is used for face recognition at airports. It's a useful tool. People are still developing, like improving it. Yeah. Any other papers that you read, maybe?
From this list?
No, generally. Like, given that we are talking about, it's kind of a JC.
I'm thinking popular papers. There's one by Sidney Brenner. So he's also like a Nobel Prize winner. And he wrote like a perspective article.
I was also going through like the Nature news features yesterday. And it's quite a nice resource just to look at some of the highlights of general research in the world. I normally don't do that. I feel like I should increase the frequency of just browsing through that site.
It was basically trashing systems biology.
Oh, so we like that?
Sequences and consequences. Yeah, very few citation count. 273 people cited it.
When was it published?
In the Royal Society. When? 2010.
Oh.
Philosophical Transactions of the Royal Society. Yeah, I mean, people, it's a good thing to read because I think it's written well.
Is that the only one in your written well column of papers?
No, there's a few, but this one I liked it also because it's like a perspective. It's not a scientific paper.
Sure.
So it's like he's just sharing his thoughts on what he how he thinks science should be done. Yeah, basically it was very fairly early, right, 2010, and he was just saying how like at that time already there was this trend of just amassing more data than we could ever possibly understand. So systems biology in the sense of like different modes of data, like not multiple kinds of sequencing, blah blah blah. You just collect all of it.
Yeah.
And he is coming from a point where he's hardcore mall biologist, right? He's one of the people who figured out I think he worked with either with Watson or with Crick, I can't remember who, to figure out the translation, like basically the codon aspect.
Oh, that is what he got the Nobel for?
I don't know if he got the Nobel for that because he's also the one who developed the C. elegans as a model system.
Okay.
So I'm not sure which one he got the model prize for, but big guy, very established. And then, so he was basically coming from that background of like having a very clear-cut hypothesis, testing that out, showing that, and he's just trashing that against the people who just like sequence a bunch of shit.
Yeah.
And it's funny because I think I fall more on the other side where I want more data and then we can analyze it. But I liked his...
I see. I think I sort of like swing between both sides. There were times when we have had this discussion multiple times about having a hypothesis-driven project versus data-driven project. Kind of do agree with him. I feel like, yes, we can get a lot of data and then just go with it and find something or the other. That will always be the case. But because I experience that also. Like right now also I have so much data, but no clear directions. So I have played around a lot and then of course found things which then become bigger things hopefully eventually. But I also like to have some clear biology.
Yeah. I mean, I kind of have to refresh myself to what his exact points were because I really read this like 5-6 years ago.
If it's really, really good, we can do a pod on it.
Yeah, maybe we should we could do that. Oh, I'm not sure if this is a whole paper, but I think it's a talk. Okay, so maybe it's not related.
from the same guy or someone else?
No, not the same guy. A different Nobel Prize winner. But I just know of one phrase which actually Dennis has printed on his has it on his wall.
What is it?
Similar in vibe, but not the same thing. But it's basically build houses of stone, not mansions of straw.
Yeah.
So basically, get like very concrete evidence for whatever little bit of story you're putting out, even though it might be very humble. And that's better than building like a very elaborate story, but that's stitched together in a very loose and fragile way. So you might build something that can be easily knocked over.
Yeah.
Yeah, that's the core idea, I guess.
Cool. Any closing thoughts?
Um,
Any non-science things that you're doing?
non-science things currently.
None.
Playing video games. Back to that for this week at least. I'm enjoying that.
Yeah.
It's been good fun. I am craving a bit of a side project. Don't know when I'll get to it, but the idea is, so I don't know if I mentioned this, but I had like I have these occasional bursts of I want to like code something, build something.
Yeah.
The first time that happened, that was like building websites, and that was fun because I learned how to like write HTML, CSS. The important thing was that was before the rise of AI. Exactly. So I really literally learned all the syntax and then wrote it, which was fun.
Yeah.
But after that,
GPT, I tried it the other day. You just tell it and it creates the website.
Yeah, you get it.
Minutes.
Exactly. So, but after that, so second version of this, I was doing the Telegram bot thing, where I did use ChatGPT heavily, and that helped me work with the Telegram API. And the cool thing about that is, I would not have been probably able to do it without the help of ChatGPT, or it might have taken just much longer.
For sure.
Right? So then now the third idea is, and the models since then have gotten better. They've gotten much better than when I last used it. So now I want to try something a bit more ambitious. So again, get the AI to help me and use it to do something I might not be able to do otherwise.
Yeah, we are so powerful right now. Like, this is really something on my mind, but I have not been able to figure it out. Given the access of knowledge we have, like it's so democratized, both of us are like anybody can do kind of anything right now. Of course, they're limited by compute power, and like there are some actual factors which are limiting them. But the bigger thing is just imagination and like the question itself.
True, there's nothing stopping you from getting started, I guess.
Yeah, like even I was also thinking initially, now that I have this tool and like knowledge as well, what is a problem that I can solve, say in India, like, go a bit further away from what I do, and then is there a simple problem that I can really make use of AI? Because I understand it, if I don't understand it now, I can learn to understand it. But I think right now the lacking thing is identification of a problem where it is going to be useful. And I'm sure there are people working on it, and it might just be like a little bit of connecting with people who are already doing something similar. So maybe I will just give this one example. I was reading up what are some real world problems that people are using AI for, because mostly it's in development, in like, IT stuff, or like creating tools, or I don't know, in maybe cancer prediction and stuff like that. But are there some real world problems that people are using it for? And there was one Nature perspective only I read, which spoke about how AI was used to measure poverty. So what they did was they just took satellite images of some African cities, and just by then analyzing the structures of houses, the streets, and like just general features of looking at a view of that location, they could then detect how poor or how rich this place is. And this was also done during COVID. So the government was trying to figure out how much money should be given to whom. And they did this kind of analysis where they scanned through, and now they have a map of, say, city X, this location, like they have a heat map of poverty.
Yeah.
And now depending on that, they are giving out money to people. So which was quite nice. And I think another way was also, as opposed to satellite imaging, you can also look at data of, say, phone transactions, or what sort of recharge people are doing on their phones. Any kind of data that you can get hold of, and then just run some of these algorithms, some of these tools to then answer a question. But for me, it was like just asking this question is a bit difficult, because I don't understand what sort of data is available, what sort of question I really want to answer.
Yeah.
But on the other hand, where I was actually getting at was that maybe I should stick to biology. Maybe I should just stick to healthcare. If I understand cancer more, maybe that is the field where I can help the most.
Yeah, probably. I mean, if it depends on what the outcome is, right? I guess if the goal is to be the most useful, then yeah, of course you want to leverage the skills that you have. But if you want to like learn something, I guess it's an open world. Yeah, you could do anything, right? Yeah, the cool AI use cases I remember noting, or at least what seems to be emerging but not so utilized, is probably like robotics and stuff. Like if you are, I saw like a bunch of videos on YouTube where people are like, they build tiny robots, right? And then so the way the robot can move is either you do like manual control, like it's on a remote, or you feed like, let's say, the camera feed to and then there's like a small scale AI model that runs locally on it to like let the robot navigate by itself real time. So things like that, it's good to have an AI model because now it can like figure out what is in front of it, where to go, but very accessible. So I think like maybe there it has been very sort of underutilized.
Yeah.
So we'll see.
Cool.
Okay.
Let's go with that.